Hello, everyone. Hi, my name is Paulina Sadowska. I work as a mobile software engineer at Allegro. And at this presentation, I want to talk with you about the newest addition to Jetpack Macrobenchmark library. There will be dedicated time for questions at the end of this presentation. But you can ask your question on chat during this whole presentation. I will answer them in the end. Okay, so let's move back to the topic. So at this presentation, I want to shortly show you what this library is and how you can use it. But most importantly, I want you to be able, after this presentation, to answer the following question. Is Jetpack Macrobenchmark library something that you need in your daily tasks, in the app that you are working on? Or maybe it's better to just use something else. Okay, so let's start from what Jetpack Macrobenchmark is. So Macrobenchmark is a new library introduced during the last Google I/O, so less than half a year ago, and it's still an alpha. And if some of you have a déjà vu, and if you think that you heard about benchmarks in Jetpack already, then yes, you are right. There is also another library called Benchmark that was introduced 2 years earlier. And both those libraries allow us to write tests that measure app performance. And how do those libraries differ? Well, most importantly, they are meant to be used in much different scenarios. Macro benchmarks allow us to measure startup performance, and they also allow us to measure how smooth scrolling of some list in your app is. And the older library, Benchmark, is meant to measure performance of the code that is frequently run in our app. And I know this presentation was meant to be about macro benchmarks, but those libraries are very similar, and to some extent they use the same mechanisms. So to better understand what macro benchmarks are, we first have to make a quick introduction to the benchmark library, so the oldest from those two. And this library, after macro benchmarks were introduced, was silently renamed in Google Docs to micro benchmarks. So this is the name I will be using from now on. Okay, so what micro benchmarks are? So both Jetpack micro and macro benchmarks allow us to create a UI test which measure performance of some part of our app. And to create such test using micro benchmark library, all we have to do is just create regular UI test class, define benchmark rule, and then create function annotated with test annotation, as we would normally do in any other test. And here in this test, using measure repeated function from the benchmark rule, we can execute code that we want to measure. And that way, by running this test, we will find out how long it takes to execute this code. So in my case, I will measure how long it takes to execute do some work function. And after we run this test, in the results, we will see that this test passed, yes, but this test will pass every time unless we make some terrible mistake and something crashes. So that information is not that interesting. Much more interesting is this number here. This number shows how long it takes to execute the code that we measure. So in my case, it was do some work function. And here we can also see how many memory allocations happen during that method call. And those test results are available here in console, as you can see on the screenshot. But we can also get much detailed results in a separate file in JSON format to further process it on our CI server. Okay, but what are advantages of using micro benchmarks? What we gain by creating those UI tests and by using this separate library, Jetpack Benchmark library, versus creating just this simple piece of code by hand. This code also measures how long it took to do some work function. And this function is really simple. It just measures time before running this function and measures time after, and subtracts those two numbers. Easy. So Jetpack Macrobenchmark library, and Macrobenchmarks also, of course, have a lot of features that are meant to make our results, results of those tests much more repeatable, and therefore also more reliable. Because as you probably know, if we measure performance, there are a number of factors that may influence final results. And the first feature I wanted to talk with you about is that Macrobenchmark library dynamically determines how many iterations are needed to measure performance of this code. So in each iteration, it checks how big standard deviation is, and then it decides if it needs more data to determine final results, or maybe it's enough. And it also discards any data that significantly differs from the average. So the number of iterations can be different in each test. If measured code gives us more stable results, it may need less iteration to measure this code. But if it gives less repeatable results, it can take even a couple hundreds or thousands iterations to determine final reliable result. So that's something that definitely increases quality of results that you achieve using this library. But on the other hand, we have to also remember that the operation that we measure have to be very short. Those operations cannot be too long, because that could make our benchmark test very, very slow. And the second feature is that this library also checks if our environment, if the environment that we use to run this test is correctly configured. And more specifically, it checks that we run this test on a physical device, because results that we achieve by measuring performance on the emulator may not be good representation of what our users see. And it also checks if device battery is charged, because it can also, of course, affect device performance. And the last, in my opinion, very important thing is that it also verifies if we run those tests, on app variant, which is non-debuggable. And I would like to stop for a moment and explain this point, because I think this information may be important, even if you don't use benchmarks, but for measuring app performance in general. So why it may be important to not use the debuggable version if we want to measure performance? That's because the performance of the bug version is not the same as performance of release version. The app that we ship for our users is much more optimized, is much more shrunk, and those optimizations are not present in the bug version. So measure code is completely different in both those versions. And you know, it wouldn't be a problem if the release version was, for example, always 4 times faster than the bug version, or if release version was always 2 times faster than the bug version. Well, but unfortunately, it's not that simple. And here you can see a graph that was shown on Google I/O. And this graph shows that the comparison, how long it took to execute some methods in debuggable and non-debuggable app variant. And as you can see, for some methods, the performance difference is very, very low or even non-existent. But from some other methods, the performance difference can be even 40 or 70%. So that's why results that we achieve measuring app performance in the bug version may be sometimes a bit misleading, because in result, we may spend a lot of time optimizing code that will be optimized automatically by R8 or ProGuard anyway. Okay, so back to the main topic. The last feature I want to quickly tell you about is stabilizing CPU frequency. So as you can imagine, when the device runs our app, at first CPU frequency gradually increases, and then it stabilizes on some level. And of course, the performance of our code will be drastically different if we run this code in this point of time, when CPU frequency was only at about 300 megahertz, comparing to the moment when CPU frequency was 2.5, 2.6 gigahertz. And that's why Jetpack Benchmark library contains a lot of mechanisms that stabilize CPU frequency. And when our app starts and CPU frequency increases, it simply discards all results that were measured during that time. And after that time, it locks CPU frequency at a certain level. And this level is, of course, not 100% of what your CPU is capable of. It's only about, I think, 80%. And that's because, well, we don't want our device to overheat. OK, but enough about micro benchmarks. At this presentation, you probably want to hear about the newest addition to Jetpack library, macro benchmarks. And as I said, this library is very similar to micro benchmarks. It uses the same core mechanisms. And here we can also create UI tests that allow us to measure performance of some part of the app. And the main difference is in which scenarios those libraries should be used. So macro benchmarks allow us to measure app startup performance and allow us to also check how smooth scrolling of some list in our app is. So let's start from how to test performance of app startup using this library. And so to create such test, we have to, similarly to micro benchmarks, we have to create a new test class. We have to add specific rule. This time it's not benchmark rule, but macro benchmark rule. And then we can create test function, just like before. In this function, we will use measure repeated from the benchmark rule. And in this lambda, we will define code that we want to measure. And this time, since we want to measure activity start, app start, we will just create an intent here with specific package and action that we define in Android manifest. And then we will use this intent to start the activity. And something that is a little bit different than in previous tests is that macro benchmark library in macro benchmark rule, measure repeated also takes couple of required parameters, couple additional required parameters. So we have to define a package name. We have to define what type of metric we want to measure. Since I wanted to measure app startup, I defined it to startup timing metric. And the last parameter is iteration, which defines how many times this piece of code should be measured. And as you can see, in macro benchmarks, we have to define number of iterations explicitly. They are not determined by benchmark library dynamically, as it was done in micro benchmarks, in the benchmark library, this older version. And the main reason is that, well, as the name says, macro benchmark library tests scenarios. The scenarios that we measure using macro benchmarks are usually long-running operations. So we are not able to perform as many iterations as in micro benchmarks without making those whole tests extremely slow. OK, and after we run this test, in the results may see something like this. And like previously, test passed. But it's not the most interesting part. This test will always pass unless we make some terrible mistake. A lot more interesting is this section. This section shows how long this operation took in best and worst scenarios, so min and max, and what was the median. And also, the additional feature that was added in macro benchmarks is that if I click at one of those results or one of those iterations, when I click it, you can see that Profiler will open. And here in Profiler, we are able to see all method calls that were called during activity start. We can see how long they took. And try to find anything suspicious if performance was not good enough. So here you can see all those method calls. Here we can see more information. Here is information about how long it took to render a frame, and you can see that in my demo app, it took almost 80 milliseconds to render one frame, so definitely something is off. And we can also see here in the section that I will expand later what memory allocation looked like, how it changed over time after when we opened our activity. So we may find some interesting information over here that can help us spot something suspicious if test results were not good in our opinion. And don't be misled by the fact that this data is shown in Profiler, because it's not a regular trace that you can record and see in Profiler. Well, because as you may remember, benchmarks cannot be run in debuggable mode, and recording method calls using Profiler needs debuggable app version. So this trace that we see here is in fact systrace. Systrace, which we can normally open and analyze in a tool called Perfetto. And this kind of trace is different from what we normally see in Profiler, because when we use systrace, we don't have access to all method calls that were called in the app. So we don't have as many informations as we would do if we used Profiler. But it does not have to be a problem, because if we need to see how long it took to execute some specific method, we can use custom trace like that. So as you can see in this piece of code, I wanted to see how in systrace how long it took to sleep for 10 milliseconds. So I've put it inside trace block. I added some specific label, and then I can find this method call in trace that I recorded during a Macrobenchmark test. And here we can see that okay, so here are the results. As you can see, sleeping for 10 milliseconds takes almost exactly 10 milliseconds. So everything is correct. Okay, so let's go back to parameters that we defined in startup macro benchmarks. Besides those 3 parameters that I showed you earlier and that are required, there are 2 additional parameters that we can use to test activity start in different cases. So the first parameter allows us to define which startup mode we want to use. And those startup modes translate to different ways our user can enter our activity. We can, for example, specify it to startup mode hot, and that way measure how long it takes to resume our activity. Another option is to use startup mode warm, which measures how long it takes to start and resume the activity. And the last option is to use startup mode cold. And in this mode, we can measure how long it takes to initialize the process, start, and resume activity. And this is the least optimistic scenario. In this scenario, we will get the worst results. Okay, and the other parameter that I wanted to show you that we can also specify in this test and can influence our results is compilation mode. And this parameter specifies if code that we measure should be precompiled. So we can use compilation mode none, which translates to no precompilation, so just-in-time compilation. Another option is to use compilation mode speed profile, which translates to partial precompilation. And the last option that we can use is compilation mode speed, which means full ahead-of-time compilation, full precompilation. And how this precompilation works, what is just-in-time and ahead-of-time compilation, and which one is used when in real-world scenarios. I think it's a really interesting topic, but unfortunately, we don't have time to cover it. So instead, I will recommend you a YouTube video, which just happens to be created by me. So in this video, you can learn how Android runtime works, how it changed in different Android versions. So if you are interested in that topic, I encourage you to check this video out. I hope you will find something interesting. Okay, so enough self-promotion, back to the main topic. We talked about app startup benchmarks. And now let's see how to create tests that measures scroll performance. So similarly, like before, we create test class, then define macro benchmark rule, and create test method. And in this method, in measure repeated function, we will define what operation we want to measure, just like before. But first, we have to define some parameters, so the package name, metric that we want to measure, this time it's frame timing metric, and number of iterations. And we also have to define something called startup block. And in this lambda, we have to define how to initialize activity, which contains a list that we want to scroll, that we want to measure. And this operation is not taken into account to determine final test results. And after that, we have to add a couple more lines of code, which may seem complicated at first, but they are very simple, in fact, because all they do is simply get recycler view that is displayed on specific screen, and then scroll this recycler view a couple of times and wait for it to become idle. And when you see this code, you may wonder, why I scroll this list 5 times in one test iteration and then wait for a recycler view to be idle? So we can do it in this kind of tests because, contrary to what you saw before, this test does not measure how long it takes to execute operation that is defined in measure repeated, so this whole block. But instead, it measures how long it takes to render frames during this scenario. So when I scroll my list 5 times, it checks how long it took to render frames in that scenario, not how long it took to scroll list 5 times. So after I run this test, you can see that results look something like this. And those results show how long it took to render certain percentile of frames. So for example, you can see that the best, so the mean result that we got for 95 percentile was 81 milliseconds. What does it mean? That means that for this best of those 10 iterations that happened here, the best results that we got, in this best result, 95% of frames took 81 milliseconds or less, and 5% of frames took even more than 81 milliseconds to render. So by looking at those results, you can see that scroll performance of this demo app that I prepared for this presentation definitely could be better. I did my best to make this really slow. And here we can also click at some result or some of the iterations and see more details in Profiler, like before. So I click it. And I will open trace in Profiler. And here we can analyze systrace recording. We can see all method calls that were called, how long they took. We can, for example, check how long it took to call onBindView from recyclerView function here. And we can, of course, if we need to add some custom trace, if we need to measure some specific function, if we need more data. And here we can also see how long it took to render frames in this iteration. And here is a section which shows how memory allocation changed over time. Okay, so I think we covered the first part. And now I hope you know what micro and macro benchmarks are. So let's move to more important part and try to answer the question, are micro and macro benchmarks something that we need? Or should we use something else? And my answer to this question is, it depends, as always. It depends on the situation we are at, and it depends on what kind of information you want to achieve. What is your goal here? Because let's say we are implementing some new feature in our app. We finished our implementation, we launched it and want to test how it works. And when we interact with our app, we see that there are some awful lags. And something's wrong. We have to optimize it somehow. So in that case, we want to find out what's happening and which methods we should optimize to get rid of those lags. And in that case, I think there is absolutely no need to use benchmarks, despite the fact that we could, because macro benchmarks allow us to see the trace, and using this trace, we should be able to find where the problem is. But in my opinion, much more time-efficient solution is to just use Profiler. Profiler is very convenient. We don't have to modify our app and write any code to measure method calls, and it's embedded in Android Studio. And it also gives us a lot more detailed information that we saw in systrace. So here you can see example of recording that was done in Profiler. And as you can see, we have an access here to all method calls that happened during the recording. And hopefully all those informations should allow us to find something suspicious and try a method that we should optimize. And of course, measurements that we see here are not very accurate. Measurement error can be pretty significant in Profiler, partially because we use the bug version here, but also because Profiler in general makes running our app slower. But if we want to just quickly find out what's happening, which part of our code base we have to take a closer look at, well, the truth is we don't need very accurate results. So Profiler is a great tool for the job in that case. Okay, so let's say we found what makes our feature slow, and we introduced some optimization, and now want to find out how this optimization affected our performance. So this time we need a bit more accurate results because we want to make sure our change made sense. And in that case, I also think benchmark tests are not something that we need. Because writing benchmark tests can take some time, and this operation that we want to measure is something that we probably want to measure just once. We want to find out if we did the right thing, and probably we'll just forget about it after this time. So using benchmarks may be a bit overkill in that case. And in my opinion, in that case, it's much better to use systrace. As you saw earlier, systrace gives us a bit less information than Profiler, but it has an advantage that allows us to measure app performance in release mode. So the results that we see here are a bit more accurate, and app performance will be more similar to what our users will experience. And on the slide, you can see how systrace recording looks like in Perfetto. And as you can see, we have a lot less detailed information here than we had in Profiler. But of course, if we need to measure some specific method or operation, we can simply add custom trace to our code, and then we can find this trace and use these results to decide if our optimization made sense and how it affected our performance. Okay, so if in those two situations there is absolutely no need to use benchmarks, is there any scenario in which we should consider using it? I think that only if we are in a situation when we have some very important piece of code, and the performance of this code is really crucial for us, and so crucial that we want to continuously make sure that there is no performance regression introduced in that piece of code, I think only then it's worth considering using benchmark, so Jetpack Benchmark library and Jetpack Macrobenchmark library to measure that part of the app. Because that's exactly the purpose of this library, creating a process that is able to automatically detect performance regression for us. But of course, it's not the only way. Another alternative may be measuring performance on real users. And this method gives us a metric that is much more realistic. So this is definitely the advantage of that approach. But it also has some challenges. For example, it requires processing a lot of data. OK, but why aren't benchmarks the solution to all three problems that I showed you here? And I only recommend using them in this last scenario. Well, because like every other tool, benchmarks and macro benchmarks have a lot of advantages, but they also have some drawbacks. And the first drawback is that it can take significant amount of time to create and configure benchmarks in your project. It's much more easier to just launch Profiler or use systrace if you want to just quickly check something out. To measure some part of the app using benchmarks, we have to create UI tests like you saw before. But we also have to define those tests in separate module because those tests need different configuration that are regular UI tests. And most importantly, we have to write some scripts and we have to add a new plan to our continuous integration service, which will run those tests regularly to detect performance regressions for us. Well, having benchmarks that are only run locally and which are not integrated into our CI, well, I think that does not make a lot of sense. I think the whole point of using benchmarks is to have automated system which will run those tests for us and alert us when something is wrong. And the next thing that may be troublesome when you use benchmarks is that those kind of tests are relatively slow because they run measured code a lot of times to get the most accurate results. And to make things worse, as you may remember from one of the previous slides, Jetpack benchmarks and macro benchmarks needs to be run on a physical device. And to be exact, we have to run them on the same physical device each time to be able to compare the results. So both those factors may introduce some problems when you want to integrate this process into your CI, especially if you want to write a lot of those tests and if you don't have a lot of physical devices available. And that brings me to the last part of this presentation. In this last part, I want to share with you my experiences with using benchmarks. I had a chance to experiment with them a little at work, and I want to share with you what was my approach, what I think went well with this approach, and what I wished I did differently. And to do it, I would like to give you some background information about why we choose to use benchmark. So as I mentioned earlier, I work as an Android developer at Allegro. Allegro is the biggest Polish e-commerce platform. And I work in the team which develops our in-house server-side rendering tool called Mbox. And Mbox is a tool that allows other developers in Allegro to define features completely on the backend side. So they can use generic elements like the ones that I showed you here. And using those elements, they can define how the screen should look like completely on the backend side. And they can also define how it should behave when user interacts with it. And this definition is sent from our backend service to our mobile apps. We have native Android and iOS apps, and in those projects, we implemented libraries that render those generic elements on the screen using just regular views that are normally used in Android and iOS apps. And because Mbox is really generic tool and it's used to render a lot of different features in Allegro app, the performance of our libraries is really crucial for us, and we obviously wanted to make sure that we don't introduce any performance regressions, especially in operations that are critical for smooth screen rendering. And that's why we decided it will be great to write benchmark tests for those cases on Android. And I will be completely honest with you, I was a really huge fan of benchmarks at the time, especially after I saw how Google works with benchmarks. If you visit site androidexperts.kia.org, you can see that they have huge amount of methods in the code base covered by benchmarks. And they have whole system which plots how performance of certain pieces of code changed over time, and also the system detects performance regressions and performance improvements that happened on the master branch. And you may wonder why also in performance improvements. Performance improvements is a good thing. Why to alert someone about it? Well, performance improvements may happen if we did a great thing and optimize something, but it can also happen if we remove some code by mistake. So those kind of alerts also can say us that something like that happened. Okay, so as I said, I was really hyped about this idea, and it was not enough for me to implement benchmark, the system that uses benchmark the same way Google did. I wanted to do it better. So I had an idea that it would be great if we could detect performance regressions before any change is merged into master branch. So at Google, it's a little bit differently. They run benchmarks on after change is already merged to master. And if they detect performance regression, they create issue to fix it. And my plan was to create script that will run all benchmarks test on a master branch, and then run all benchmark tests on the feature branch using the same physical device, and then compare those results. Nothing complicated. So, and those results were published as a comment to our pull request. And in this comment, we can see if there was any performance regression or improvement, and how long it took to execute measured functions. And the idea was that only after someone ran those tests and only after someone analyzed this report and accepted it, only then we can merge this branch to master. So the idea was not bad on paper. At least I think so, but after I implemented it, I came across some problems. And the first problem is that those tests are really, really slow. And even for those 3 simple benchmarks, it was a problem. And another problem was that those results that we achieve are not as repeatable as I wished. And to make those tests, and of course I can make those tests more reliable, but to do so, I have to run those benchmarks couple more times and remove any outliers. But again, it's a little bit problematic to do because how slow those tests are. So the result is that, yes, we use benchmarks and we ran this plan when we introduced some changes in the code that those benchmark tests. But we don't run this plan before every merge because it would slow down our work. So knowing all that, would I still use benchmarks in that scenario today? I think yes. Benchmarks are a great tool to detect performance regressions. But today, I think I would implement this a little bit differently. I think now I would try using approach that I used at Google. And I would try to measure performance on master branch after each merge. That way, of course, we would find out about performance regressions a little bit later. But on the other hand, it would not be a problem that those tests are that slow. We would be able to run them regularly, maybe at night, and it would not affect our workload. And that brings me to my final point that I want you to remember from this presentation is, and that final point is to choose the right tool for the job. I think it's really important to know a lot of tools that allow us to measure a performance, not only benchmarks, but also other tools. And it's really important to know their strengths, but also know their weaknesses. And that way, we are able to choose which tool will be best to solve the task that at hand, the task that we are currently want to solve. And that will be all for today. Thank you all for listening. And as I mentioned earlier, I have YouTube channel, and I also write some articles on Medium from time to time. So if you are interested and you want to check it out, here is a link. Also, if you want to work with us in Allegro, we are currently looking for Android developers in several teams. You can find all the offers on allegro.pl/praca. And if you want to work in my team, in the team that creates server-side rendering library that I shortly talk to you about, here is the direct referral link to the offer. Okay, and that's really the end. If you have any questions, I will try to answer them. So I will take a look at the chat. Okay, so there are no questions apparently. So I think thank you all for listening, and have a nice rest of the day. Okay, so I think there is one question. Okay. Okay, I'm waiting for this last question. I hope. Okay, so when you compare results from benchmarks, okay, so the question is, Paulina, when you compare results from benchmark run on master branch with results from feature branch, and this is the question from Grzegorz. Well, the plan was to, if I understand this question correctly, you ask if when we run this plan that measures performance on those branches. So the plan was to run those tests before every merge, and well, if it was possible and if those tests were quick, we could even launch this test automatically after each commit, but it was not realistic from very beginning because there is limited source of physical devices that we can use, and it was not realistic. But the plan was to run those tests manually before you are able to merge. If you remember the slide, this performance test bouncer published this report, but it also approved a pull request. And my plan was to require approve from performance test bouncer before, and so no one will be able to merge any branch to master if they didn't got approved from this performance test bouncer. But this test bouncer gives approve always, no matter what are the results of those tests, because if the test results changed and you are okay with it, because you added some new feature, it should not be a blocking thing. Okay, so Jakub asked if it's possible to use some ready-to-use tool to integrate benchmark tests with CI and avoid custom. I think yes, you can. There are samples from Google that you can check out that use benchmarks, and I think they use some ready tool. But it was not possible in my case, so I don't know any details. And Arek asks why the name Mbox. To be honest, I don't know. When I joined the team, Mbox was still not production ready, but it was pods, but the name was there. I think I would have to ask the author of the person who who chose this name. To be honest, I don't know. We have another tool in Allegro on front end, which is called OPBox, and if I think about it, when I think about it now, Mbox is probably the mobile version of. Well, probably it's also because it can build mobile apps from small boxes. But I'm not sure, to be honest. Okay, so I think there are no more questions. We are also there is there is 4:10, so we finished. So if you have any more questions, you can ask me on chat. And thank you very much. Have a nice rest of the conference.